Good afternoon, everyone. The topic I am going to discuss is about the case study on experimental analysis of a cold store integrated with phase change material. Introduction. In the refrigeration and heat changing systems, latent heat storage is frequently used due to its high energy saving potential and high system efficiency. Phase change materials are used to store energy and balance temperature changes in different fields, including electronic devices, automotive industry, buildings, and heat storage systems. In recent years, PCMs have also become a widespread solution as an alternative cooling and heating method in applications. Using a convenient PCM combination and an encapsulation tool may lead to major benefits without the need for extra design changes in refrigeration systems or enclosures. The aim of the study is to monitor the indoor temperature changes of an actively operating cold store under frozen storage condition at minus 18 degrees Celsius in the presence and absence of PCM load to present the useful function of PCM during an operational failure or electricity storage. Then the materials and methods. The internal dimensions, that is the length, width and height of the store, are 212 x 113 and 218 centimeter cube respectively. Within the cabin, the presented geometry, it is established to show the circulation of the air sweeping all over the capsule surfaces. The sidewall, ceiling and floor of the cabin contain polyurethane rigid foam blocks of 1880 mm as main insulating material. Macro capsules with PCM are mounted on the ceiling and walls of the cabin, and they cover about 10% of the total heat transfer surface area. The parameters measured by the sensors include the indoor temperature, the PCM temperature, and high density polyethylene macro capsules and ambient temperature. Then, in this research, these three parameters are recorded with 10-second intervals. In the experiment, 62 HDPE macro capsules contained approximately 62 kg PCM were used, and the total surface area integrated with macro capsules containing PCM was about 2.5 meter square. Each experiment was repeated twice to observe the reproducibility of the data, and the mean values have been reported. Prior to monitor the indoor temperature changes under different conditions, the cold store was operated for 24 hours to reach minus 18 degrees Celsius and equilibrated between minus 16 and minus 18 degrees Celsius. In data evaluation, minus 4 degrees Celsius has been taken as boundary value since it is the critical temperature for safety of some perishable goods. Results and discussion. In this research, the temperature change in the PCM loaded cold store have been monitored at three different ambient temperatures, 24 degree, 20 degree and 30 degree, whereas the thermal behavior of the cold store in the absence of PCM has been monitored at 24 degree ambient air temperature as reference. The repeated measurements indicate that the observed thermal changes are reproducible after equilibrium of the cold store for 24 hours between minus 16 and minus 18 degrees Celsius, and the observed fluctuation of the ambient temperature are greater than or equal to plus or minus 2 degrees Celsius in the laboratory. The table in the right side shows the change in time to reach minus 4 degrees Celsius in cold store and PCM macro capsules under different conditions. Then, therefore, it is stated that the PCM load in the cold store, it has a direct effect on indoor temperature and maintenance. The resistance of PCM against heat transfer into the cold store functions is sensible heat from in solid and liquid phases and also in latent heat from the form during phase change. Besides, the PCM itself reaches is 44,790 seconds, 45,930 seconds and 76,140 seconds to minus 4 degrees Celsius at different ambient temperatures, which are long enough to provide a sufficient thermal load for temperature maintenance in the cold store. Conclusion. In this research, the cold store operating under frozen storage condition at minus 18 degrees Celsius have been investigated to determine the useful function of the PCM load during an operational failure or electricity shortage. The results indicate that PCM load covering 10% of the total heat transfer surface area provides significant temperature maintenance and all ambient conditions and prominently extend the time to reach minus 4 degrees Celsius. Since frozen storage conditions are very important for safety of the stored perishable goods, the presented research provides valuable data not only for cold stores but also for refrigerated vehicles which are used for long distance transportation. Thank you.